Welcome to the Keynote Theatre. My name is John Booth. I'm the Managing Director of Carbon Through IT Limited and a member of the Data Centre Alliance's Advisory Board. And it's my absolute pleasure to introduce Bertrand and his panellists for this debate. But before we start that, everybody has to leave the auditorium at the end of the session and leave through that exit over there. So without further ado, over to you, Bertrand.
Thank you very much, John. Also from my side, a very warm welcome. Good morning, everybody. Welcome on this key panel discussion on AI factories and European digital future. To start with, I think it's common sense to say that today when we talk about artificial intelligence, it's not anymore a software revolution. It's turning into an infrastructure race. If you look at the United States, how fast they are deploying AI infrastructure campuses, and they are existing, it's not a plan, they are there. If you look in Asia or in the Middle East, how they are, the governments, authorities are aligning together with industry vendors, they are ahead. And if you look into Europe, well, we have talent, we are investing, but the key question is speed and maybe cooperation. And if we don't manage in Europe to bring this infrastructure together, the innovation will move away. And innovation is competitiveness for our societies and companies. So to nail down the subject today, we have three leaders from the full ecosystem. We have Carlo Ruiz, who is Vice President Enterprise and Operations at NVIDIA. We have Jason Madison, Head of Product Management at nVent. And we have Abed Jishi, CTO of Xscale. Welcome, gentlemen. Thank you for accepting being there on stage today, this morning.
Thanks for having us.
So, to start and warm up a little bit, very spontaneously, what means AI factory for you? Hello, to start?
Well, over the last day I've been walking around, and I think the AI factory is not a new definition for all of us here, right? So I think we already established it's more than a data center. It's something where we generate intelligence, and it's also a revenue generator. But our CEO Jensen, he came with a new concept earlier this year. He said AI factory is really about a 5-layer cake. There's another way to think about it. So one, on the first layer, you need to think about energy. Second is the chips. It's not just about one chip, a GPU, it's a lot of chips that you have in there. The third one is the infrastructure around it, the Shell, but also the companies that operate it. And then on top of that, you have the models, and then you have the AI applications. And so that 5-layer cake, for us, that's an AI factory, and we need to create that whole ecosystem and the collaboration around it.
Okay.
Yeah, so I'm from a cooling infrastructure company, and so my view is obviously more power and cooling focused, and I see AI factories as extreme power and cooling density, the new data center, if you will, and with advanced hardware, advanced software, intelligent monitoring, management, and automation.
For me, as a developer, I look at things slightly in a different perspective. So an AI factory for me is a purpose-built data center, so where we have a tight coupling of power and cooling systems, eventually to exactly do what Luis just mentioned. We look at GPU clusters. It's a very different view when in comparison to a traditional data center, where our load ramp is predicated by different server racks, so load-end server racks and load ramp the facility. With an AI factory, we look at complete clusters. How do you energize complete clusters in stages? And of course, the densities per rack 5 times of what we had seen in comparison to traditional data centers.
So we're not talking anymore from just a denser data center, but a much more industrial, complex infrastructure or system. So, but what, I mean, if you compare to conventional or traditional data center, what is the fundamental change?
There are many big changes that we see, and also how, as an industry, we look at the data center and also the metrics that we use, the KPIs. So in the past, we might have been looking at the number of chips in there, or the power usage, the wattage, right? And maybe the gigahertz is inside of the computing nodes. And now we see we're moving away completely from that, because an AI factory produces tokens, right? The units of intelligence. So everything is now measured in tokens. So, for example, how many tokens can I produce per watt? Or for every dollar that I spend, how many tokens can I get out of there? Or even most important, what is the revenue I can generate per token? So you see those metrics are changing completely. I also noticed that in the industry, right? So there are changes there. If you look at industry analysts like SemiAnalysis, they do a lot of work there, and we come with metrics of measuring the AI factory in. If I put 5 million of investment into a Blackwell AI factory, I can generate 75 million of revenue in tokens. So we go to different metrics as we are building the business case. And then maybe the last one, I see also we need to accelerate. In the intro you said something about that as well. We need to go faster. And so the question becomes, with this rapid technology adoption, is from the moment I have the idea and my investment plan ready, what is the time to produce my first token? And that's another measure. I think that's important for the industry. How can we go from the first idea to the production and accelerate that time?
Thank you very much. Well, I'd like to pick it up what you said on. We used to talk of watts, and now you're talking tokens. That's already a sort of structural shift, at least from our perspective. Abed, what is, as a developer, the biggest challenge for you as an operator when it comes to deliver AI capacity?
If I look at Europe, I think I can narrow it down to one thing. I think speed of decision making. That comes from 2 different constraints. As a developer, we look at timelines, exactly as Conor mentioned. Timeline to find a site, go into due diligence, go into permitting, and kick off construction. And if you look at that timeline to turn on the site into operations, we have 2 critical timeline impacts that are driven not by the developers, but by external factors. The first one is permitting. And we're looking at schedules of 12 to 18 months to do an environmental or building permit. And to be honest, I've worked outside of Europe as well, and I can tell you with very high confidence, these are one of the longest permitting cycles I have witnessed in my career. So that's a challenge. It's a challenge that we cannot control as developers. The second challenge is speed of utilities to upgrade the grid. There's a statement we say at HCO between us. Megawatts on paper are different than megawatts delivered. So we have a site, we found a site, we have a line of sight to power, but the utility to take a decision to upgrade the grid might take 2 years. And then the upgrade cycle starts. So every little decision through the permitting and the utility upgrade cycle pushes my deployment and capital deployment quite significantly. So these are the things we do not control, and I think, as you've mentioned rightly yourself, how do we narrow it down and how do we accelerate deployment? And I think, squeezing a 2-3 year cycle of decision making when it comes to permits, environmentals, plus utility upgrades, that would speed up deployment significantly. What we see today. So I'd say that's the main challenge we face.
So beyond time to market, you really mean regulations needs to be improved or accelerated, and we are the grid readiness.
If I may, we are all for regulating the data center industry. We're not against regulation, but submitting a building permit for a data center, especially when we have those systems already pre-industrialized. A generator is a generator. Emissions, noise is the same. And we can model generators, model mechanical plants. That is not a very challenge. Engineering skill set in Europe is so high in comparison to the world. This is not a challenge for us. The challenge is we have pre-industrialized systems. When I submit a pre-industrialized design to a local council, the expectation from us is that that permitting cycle is also pre-industrialized. We don't want to go into conversation every time in every jurisdiction. And that kills our schedules. And eventually we report to investors. And as Carlo mentioned, my capital deployment into a jurisdiction is tied into risks. And permit and utility are the two biggest risks we face.
If we look more into the infrastructure itself, Jason, you've been deploying already liquid cooling in AI factories. Was mentioned in the US. This is one of the best reference there. What are the main challenge you face when you need to really scale up on different campuses and so on?
Yeah, really good question. So first, I think they all recognize that there's a tremendous shift from air cooling to liquid cooling in the industry, right, to support AI data centers, AI factories going forward. And so the first challenge, quite frankly, is information awareness. There's standards, best practices and guidelines are just now being developed and being driven out by whether it's ASHRAE, TC 9.9 or OCP standards bodies. Designing a secondary fluid network for a rack of NVIDIA GPUs is not the same as designing the fluid loop, on the primary side, the facility's water side. Very different systems. I've been in, some other conferences and I've seen panelists get on stage, and my favorite quote was, if you can't drink from the secondary fluid loop, it's not good enough for the NVIDIA equipment. But there's truth to that, right? Everything in the secondary fluid loop has to be wetted material compatible, right? You've got cold plates, if you have millions of dollars of compute sitting in a rack, microchannel cold plates, the materials that you use are ultra critical, right? And so whether it's stainless steel, different rubbers, but there's certain alloys and materials are absolutely not allowed in that loop. And so what that does is that now requires, we talk about stainless steel, for example, a tremendous strain on the supply chain, right? So right now, one of the bigger challenges is supply chain globally, right? There's how many manufacturers are there in stainless steel industry that are focused on deploying secondary fluid networks 5 years ago, 3 years ago, 2 years ago, and the demand that's coming now and surging is incredible. So, from our perspective, it's all about globalization, global footprint, and having supply chain to be able to support the very specific needs for precision cooling to support these AI.
So not just a technology topic at first. You mentioned supply chain standards, so it's really managing, as you said, the ecosystem. So I guess it leads us to so how we do that, and leads us maybe to architectures, all of that. So you've been developing 4 NVIDIA architectures. So what is the advantage of doing such architectures, and especially you've been developing these designs, these 100 megawatt designs? What does it bring, and how do you manage all the risk that we were mentioning before?
Yeah, no, absolutely. So again, with a lot of the gap in information awareness in the industry is moving very, very quickly, right? Trying to go from air to liquid cooling. And where do you go to get the information, and who do you turn to as a trusted source? So reference architectures, that we've been putting together for NVIDIA offering, Siemens and NVEN. You have reference power, reference cooling architecture that steers what CDUs to use, what are the secondary cooling loops, right? Have a trusted source or a trusted provider, like something that has the stamp of approval that will meet the flow requirements, right? The redundancy, the resiliency, meets the welding materials compatibility specifications. So, I think that having reference architectures, first of all, it kind of it settles some of the uncertainties and the unknowns in this space because this industry is moving very, very quick. But the second thing is now it brings an element of predictability because now you know what the design is, right? So now we can work with our supply chain and we can say that we know what the design is, right? And so we can forecast better, right? Based on a known design rather than a lot of the unknown that could be occurring in the industry otherwise.
Thank you. So, Carlo, how do you react to what Jesse just mentioned? I mean, if you look at the technology layer from your side, is, for example, modularity or liquid cooling critical for you? Or, I mean, now, not in future?
Plenty for everyone to go after, right? That's also in fact makes it easier for everyone in the industry to collaborate. We talked about reference designs, and I mentioned that a little bit on the compute side and on the networking. But we see that we need to avoid going into bespoke solutions, right? Or the practice of retrofitting old data centers and so on. We need to see where we're moving next. Today we're already on the Grace Blackwell Vera Rubin. And so with the team that we have here as well, we're discussing with all the stakeholders, where will we go in the next few years? So that everyone is ready to move there. And we have taken the opportunity to work with all the partners to create reference designs that are not only on the compute side of things, but they cover the entire data center landscape. And so we created something called DSX, which is a complete reference architecture going for AI factories up to 1 gigawatt. And by collaborating and focusing on that, we think we can go faster together as an industry. So for us, partnerships and that part of the cake, and also in all the other layers, and there when we work with other references, they are absolutely essential to move forward.
Jason, how is it for your partnership? Do you see it as an accelerator or sometimes it can slow down?
I agree that partnerships are essential, especially now, given the complexity. Right, what we're talking about here are these have to be solutions, well thought out, integrated solutions, whether it's between the power and the cooling infrastructure. Right, with air-cooled systems of the past, you could fundamentally have a server show up in the loading dock, and someone's going to find a rack to be able to put that server in and connect the network to it. Things are going to be pretty good, right? You'll make that work. But today, fundamentally, right, the cooling infrastructure, all the way from the facilities, has to make its way all the way down to the chip, right? So that integration, right, the complexity of that integration is so monumental, right, that you have to have partnerships, right, to be able to talk to, from the facilities water or the facilities supply side, the chillers, to the secondary cooling loops, to the power delivery architecture. Power delivery architecture, not really touching on that, but we're about to see some fundamental shifts in the industry. Tremendous power at rack scale, and I've been in this industry for 29 years, and it was very common for me to talk about a 10 to 15 kilowatt rack, challenging your typical legacy air-cooled data center, and so we're talking north of 100 kilowatts now, right? And precipitously growing. So partnerships are essential, right? And that integration across the different cross-functional ecosystems is paramount.
And Carlo, when you look at the entire ecosystem of the AI factory, how do you manage that one constraint on the power or one constraint on the liquid cooling or the automation is not stopping the whole system or slowing down the system? Because it's also where partnerships are crucial.
Partnerships are key, and it's a complex beast. So we took some of the learnings and some of the technology that we apply in other domains, We have been quite busy with physical AI, with simulation, with robotic self-driving cars. Why not apply that technology as well to the data center, to the AI factory? So we came up with the concept of taking our super realistic, physically accurate digital twin technology called Omniverse. And we have a great collaboration there with Siemens in place. Because all of this, even before you start to ship the first infrastructure, you want to design, simulate, physically correct the liquid cooling, the thermals, and so on in that digital twin. So that's something that we put a lot of emphasis on, also in the partnerships that we have, so to make also the reference designs easier, to see how all the different components from all the different partners fit in here. And even before you get started, you know that this will work and it will be correct on site. And then during the lifetime, of course, and the operation of the AI factory, then again, that digital twin comes in very handy, right? You can use it as the operating system for that AI factory and use all kinds of smart AI technology to manage the cluster, but also help with all those workloads, of course, that you need to distribute throughout these, quite often very large environments. So very interesting innovation on that side of the AI factory as well.
And then if we look a little bit more on going back to more European focus and looking also at the time we have, how do you see the biggest challenge for Europe as a leader, European developer, operator, when it comes to AI? What we need to change in the next 12 to 24 months? And I will ask you as well, but maybe more from the US perspective.
I would go back to what we started this conversation with. I think speed of decision making. Let's stick to this point. I think for us it creates the highest value. Developing AI factories, and maybe I want to close maybe with one sentence. And this is coming from experience. I think regions that adopt the industry and support faster regulations, three things most probably would happen. So all workloads will go to that region, all investments will go to that region, and all innovation when it comes to AI will go to that region as well. So these three elements we have seen happening in different countries outside of Europe. US definitely is a big example, but we see it also in the UAE, we see it in China. And if you look at those governments, they really looked at time to market. So how do we get from technology or design or engineering to time to market? The major challenge always when it comes to that is always the life cycle of the GPUs, right? It's so short and time to market becomes of the essence. So regions that adopt that concept and look at AI as an opportunity instead of just dumping regulations and hindering development will benefit significantly.
Jason, Carl, how do you see that really a critical point of view as US major player?
I would just, speed is important, and in North America, right? Again, I talked about the standards bodies, so I think it's important that there's involvement, right? There needs to be involvement in those standards bodies, right? Europe has to be, European members need to contribute and participate in the ASHRAE TC99 and the OCP standards bodies and help influence, but also be an early, get that information as early as possible, right? Because that's key. And then just obviously, like we've been talking about, definitely lean on reference architectures because that's going to allow you to move fast.
NVIDIA, we're a strong believer in sovereign AI, that every country should have master its own destiny and bring the critical AI infrastructure in place, right? So we have seen that Europe is accelerating, right? From where we were 2 years ago, where it was only about ambition. Now we see several countries going into execution, so that's really good, but we can go faster. We should avoid bespoke projects, work more from reference architectures, work as an industry. And I heard some very good suggestions also how the governments can help to accelerate and move faster. So good things happening, but we definitely should go faster and bigger.
And I remember your CEO in Paris at the GTC mentioning that artificial intelligence is the people intelligence.
It is.
Each country
It
needs
is.
really take its destiny. But gentlemen, thank you very much for all your input. I see that Europe is having a lot on their plate on our agenda, and we need really to accelerate. Maybe it's an appel to if there is any utilities or authority in the audience to maybe help the industry to move faster. Thank you very much, gentlemen. And if there is any questions, we'll take it outside at the semester.
We've got 4 minutes.
Thank you.
4 minutes for questions asked.
No,
Anyone-
we'll do
anyone-
it.
no?
We'll do it at our booth.
Okay, do it outside. Okay, no problem. Okay, thank you.
Thank you.
Right, unfortunately everybody does have to leave the auditorium, so if you'd like to make your way